All right, example 6, it says evaluate the function f of x equals x cubed plus 4 to the x power over 1,000 for all those numbers and guess the value. And then evaluate again for these and guess again. Okay, the point of this problem is to get you to understand what close means. Because these seem kind of close, right?
Mm-hmm.
All right.
They're not at all.
But they're close-ish. Okay?
Yeah.
But these are much closer. All right, and these are going to give us more accurate results probably. All right, but anyway, let's just try it out. So, go to y equals, clear that out. Go type in the equation. Now notice it's x cubed, so I'm typing x caret 3. And again, anytime with these new calculators, when you hit the caret key, it brings you up to the power level. You're in the power level until you press the right arrow, get back down to the regular level. Then it's plus. Now it's 4 to the x power, so I do 4 caret x, again, to the right to get out of the power level, divided by 1,000. Notice I didn't use any parentheses on that one. I didn't have to. I've got a single object, 4 to the x on top. I've got a single object, 1,000 on the bottom. It's just a simple fraction. All right. If you put parentheses 4 to the x divided by parentheses 1,000, that's not wrong. It's just you're typing a lot of parentheses. Don't need to be there. All right. So just keep in mind when you have multiple pieces, something plus something or something minus something on top and bottom. That's when the parentheses have to go around it. Also, I'd say if it's got something times something, put parentheses around it. But just a single object. All right. Our first table starts at 1 and goes down by 0.2s all the way to until we get to 0.11, 0.8, 0.6, 0.4, 0.2, and 0.1. And our answers are 1 point, looks like 004. 0.515, is it 8? 0.5150. 0.2183. 0.0657. 0.0093. Where's it? 0.0093. 0.0022. Okay, so we're using this getting closer to x idea, and we look at the outcomes, and looking at these outcomes, what does it look like the answer is going to be? 0. Looks like 0, right? So my guess on this one is 0. That's what it looks like. As far as I can tell, it looks like it's dropping down. It doesn't seem like it's going to be going below 0. It doesn't look like it's negative, right? 0 seems reasonable for the choices we made there. Okay. Now we get in a little closer. We're trying to make a better guess by getting closer. So if I go up here and clear out my chart,
can you just go over top of it?
You can. I just like to leave them out so there's not like some random number left over. All of a sudden I'm looking at stuff. So 0.04. All these numbers are closer than 0.1, obviously. 0.02. 0.01. 0.005, 0.003, 0.001. Then we get 0.00112, 0.00104, 0.00101, 0.00101 again, 0.001, 001. And those last two 0.001s are actually 0.00104 and 0.001001. We went 6 decimal places.
That's.
All right. So based on this chart, what do we think the answer is? 0.001, right? That's the actual correct answer. Now, check this out. Every problem we've seen so far, we put the number in, what happens? We get error. Watch what happens when we put in 1. Or is it 0? 0, right? Hey, look, we got an answer, and the answer is exactly 0.001.
Once you put
Okay.
0.001, then it would say.
Well, we did that, 0.001, right?
Yeah.
But anyway, you put in 0, you get the exact answer. Now, here's the thing about limits. If this number does not make this expression undefined, putting that number in gets you the right answer. Let me say that again so everybody heard me correctly. If the number that x is approaching does not make this undefined, does not cause division by 0 or something bad to happen like that, then if you substitute that specific number into this specific expression, the answer you get is the answer to the limit.
So can we just do that?
I'll give you an example. If I have limit as x approaches 7 of x, the answer is 7. Because 7, right, doesn't make it undefined. Right? If it said limit as x approaches 2 of x over 9, the answer would be 2 over 9. Put 2 in, 2 over 9 is the answer. If you can put this number in this expression without causing it undefined, that's the answer. That is legal. That's something we cover in 2.3 actually, but threw it in today because it happens to work on this one. All right? If they give you specific numbers to pick, do it, but just know that putting the exact number into this exact expression will get you the exact answer. All right? If it causes an undefined, if it causes error, you can't do that. Then you got to do this, get a really, really, really close thing and making a good guess. All right? But just know that 0.1 is not very close. 0.001 is. So sometimes you have to get really close to make a good determination. Even though it looks really good before that, getting really close gets you much more accurate.
Yeah, I tried it. It worked.